Hello everyone. Our team designed a system called multi-dimension rating of restaurants based on sentiment analysis. And here we shot a video to present our achievement. First thing we want to present is the novelty of our project, which is also our motive. When we open Yelp and find a restaurant, we will see the picture like this. There is an overall rating of the restaurant, but it can't really help us when we are critical about one or some attributes of a restaurant. Yelp has a function allowing people to post reviews about the restaurant. So what we are about to do is to make the ratings more specific based on the review data we collected. Just like we showed, we set 5 attributes of every restaurant: price, miscellaneous, ambience, food, and service. Therefore, we can learn more about the restaurant and choose from them more wisely. And Yelp can use this rating system to recommend restaurants to users more intelligently. The datasets we use include Yelp Challenge dataset, SimEval dataset, and Twitter Tweets dataset. Yelp dataset includes huge amount of raw data. SimEval dataset is used as a training set for subtopic classification. Twitter dataset is used as our training set for the RNN to do sentiment analysis. It includes 60,000 tweets. For deeper exploration of Yelp dataset, we check the distribution of restaurants of different ratings and the distribution of average numbers of reviews of restaurants. We found a total number of over 50,000 restaurants and nearly 3 million reviews, and these are data we will use to realize our application of multi-dimensional. The architecture of our system is as shown. We collect raw data first and gather the restaurant review after data cleaning. We then extract subtopic from the review and classify them by category of the subtopic. We put them through a recurrent neural network and do sentiment analysis on review text. So we get the polarity of the review and therefore rate them by positiveness and negativeness. Now we will focus on the technical depths of our system. First thing we will introduce is the pre-processing of the raw data. We read the files of business and review. From the business file, we read the business name and business ID, and from the review file, we read business ID and review text. Using the ID to align data we selected, we create a list to store the restaurant review data. To process the review, we first separate the review paragraph by stop symbols and extract subtopic and adjective pairs. We applied the Stanford Core NLP algorithm to realize it. Here are some examples about how the algorithm works. Next, we want to talk about the concept level hierarchy. We use Princeton WordNet algorithm to do subtopic classification. You can see the level 2 has words we extract from the review text. Then we use pause-based sentiment similarity to classify those words into 5 categories in level 1. And these are all attributes we have for a restaurant as level 0. To do sentiment analysis, we build a recurrent neural network to determine the polarity of the sentence and therefore decide the rating of a certain attribute of the restaurant. When we have different inputs, we output positive and negative and give a rank of certain attribute of the restaurant. The core technique in the RNN is the LSTM cell. It has the same inputs and outputs as an ordinary recurrent network, but it has more parameters and a system of gating units that controls the flow of information. We use concatenated LSTM cells to map from the entire history of previous inputs to each output. Here we want to show you some results. The picture above is the data structure of the restaurant review data. It stores business ID, business name, and review text. The picture below is the output of our RNN. We rate all 5 attributes for every business ID. After introducing the whole system, we want to show you the business value of our application. About 70% restaurants are covered by Yelp, so this app has huge influence in our daily life. From these 2 figures above, we found that the rating of restaurants influences the reservation availability significantly. Every half-star increasing in rating will result in 19% decrease in reservation availability during peak hour, 6% increase in customer flow, and 4% increase in revenue. And every whole star increasing in rating can boost 5 to 9% more revenue for a restaurant. Now recall the distribution of restaurants. We can get the conclusion that the business owners really care about their ratings on Yelp. Also, from the figures on the right side, we found that the reviews of the restaurants have huge impact on users too. Our application can help both business owners and Yelp users. By rating the restaurant multidimensionally, the restaurant can attract specific customers and result in increasing rates. The users on the other side can choose restaurants more wisely if they care more about specific attributes of a restaurant. Finally, let us show you how our system works by a demo. So here is the website of our system. The searching square presents our main function. Below it, we show example types of food included in our system. On the bottom of the page is ways to contact us. Now let's go back to our main function. We set 4 choices for users, which is the same as the attributes we set for every restaurant, but miscellaneous because it is not a concern of the users. For example, we want to go on a date. We would like to go to a restaurant with good ambience and food. So we can click on ambience, food, and click the find restaurant button. Now, here are the top 3 restaurants we will recommend to you. The scores on the right is the average score of the attributes you choose, and the multi-dimension rating is listed under the name of the restaurant. Users can then choose one that he or she likes. Well, that is the end of our introduction of the system. Thank you for watching this video.